Yo, what's up, everyone? So, this is the last review sheet, um, which I'm thrilled about, like, really thrilled. Just pretty tired right now, so that's why I'm not, like, off the walls. Um, but I'm pretty excited about how the whole thing went, and this is the sixth review set. But don't forget that there's a seventh review set. I'm just not going to put any videos up on it. And the reason for that is it's like inference, and we spent all of online school talking about inference and actually covering all of it. So, um, also because I think the goal was like this, the less videos possible, the least videos possible, while also covering like everything, so that it's not as daunting. So that's why I went with only two videos for the last two sets and no videos for the last set. But the big resource, if you're super dedicated, is going to be the answer keys for that inference. So once you finish everything else, you definitely have to go back to do inference. Like, it's a really important topic. Um, but use the answer keys. And I'm going to have office hours really close to the exam, like the day before. So that could be a time to ask questions. So yeah, I hope you guys enjoyed the review. But yeah, the reason I like this question is it really just asks you to kind of define a few keywords. And because this AP could have a lot of different sections per question, it's likely they could kind of ask you some kind of definition-based questions. So this kind of covers the basic definitions in an experiment. And all that changes between an experiment and a normal study or a normal survey is that you are doing something to a group of people and testing the results between them. You're not just asking someone like a fact about their life, which is what a survey is, but you're actually trying to impose something and figure out like its effect on a different variable. Okay, and that sounds like a lot. It doesn't sound like that familiar compared to a lot of what we do, but it actually just kind of creates data for us to make significance tests, make confidence intervals, etc. So this question is testing garlic oil as a non-toxic bird repellent, which is a really, really interesting question. I really don't know where they get their pool of questions from. For the sake of time, let's just continue. But so basically, they want to test how effective this bird repellent is, and they have different rates at which they're testing. And each of these is a treatment that you could get. Okay, so think that they're trying to test these birds, and they have 40 birds that they're using, and they're going to put 8 birds in each of these 5 concentrations of garlic oil. Okay, and they're going to try to see their reaction to it by measuring how much food is consumed. Okay, so those are the big things it's talking about. And when you see treatment just means what are you doing to some people, and what do you like. So treatment just means what are you doing to some people. Sometimes you don't do anything to the other people, and that's the placebo. But sometimes, and there is a placebo because it's 0 here, but the treatment is just what are you doing to see if it has an effect. Okay, and if you want to think of this kind of in like medical terms, because a lot of times experiments work really well for science, think that like if you're trying to cure like some disease like coronavirus, you're giving a treatment to patients and seeing its effect. Okay, so if it asks you what the treatment is, it's always going to be what's happening to the patients. So we can say the amount of garlic oil, concentration of garlic oil. Then the second thing it says is the experimental units, and that is just who are we studying. And a lot of times it's people, most of the time it's people, but it could also be animals, anything that could, I guess, respond to something like a stimulus or stimuli. I don't know. I'm not sciencey, but yeah. So the experimental units in this case are the 40 birds, because the 40 birds are receiving the treatment. And then finally, 3 is the response that will be measured. And another word for this would be the variable. And remember that the response variable is one way to put it. My handwriting is extra bad right now, and it's like the last lesson. So just remember me how I was, okay? I'm just really tired. Just remember me how I was. Not about my handwriting. What if I just whipped out the SpongeBob V right now? I tried way harder, but it looks kind of goofy. It's fine. Anyway, this is the variable. What are they trying to figure out? And they're trying to figure out if the garlic oil affects how much food the birds eat. And all of this you take directly from the question. Concentration of garlic oil is what it says right here, okay? And then the 40 birds. And what is happening to the 40 birds? They want to measure it with the number of food granules consumed during a 2-hour period. And you can just write the whole thing, okay? So this one, like, yeah, just write the whole thing. The number of food granules consumed. So that's that. We just did experiments. So look, like, have that in your repertoire of notes. So have that in your repertoire of notes in case they ask questions about that. Then the rest of this is not related to experiments, but just talks about like what should you do on the AP if you see something kind of random. But usually the random stuff is decently common sense. But this is the data that they got from the set. And what I don't like about this is this last row is pointless. Okay, so when I'm reading this is just saying they're putting 8 birds in each of this. But that's not really data. That's just saying that they split it up. What's really happening is we have the treatment, which is like X, and the food, which is like Y. And it's just saying we want to construct a graph of the data to investigate linear regression, which just means this question is looping us back to scatter plots and how you can make data from an experiment and turn it into a scatter plot. So just like what we were just saying, concentration and food, we can graph them, and each bird in this case, or each set of 8 birds, is going to be a data point. It's going to be like, a crappy scatter plot because there's only 5 data points, but that's definitely how we can draw this, okay? I'm going to draw it, but so you should draw it too, and the video is just going to kind of skip to that. But then I'm immediately going to talk about 2, which asks, is linear regression appropriate? We're going to make a graph to see if it's appropriate. My thinking here is this variable goes from 0 to 0.5, and this one goes from 20 to 60, basically. So that's how you always start a graph. And 20 is close enough to 0, so 0 to 60. So then I would count them up and then figure out what's going to be a good interval. Okay, so that's our graph. And this is cool, and I like this because this is a little bit different than some of the other scatterplot questions we had. But what 2 basically says is, based on your graph, do you think linear regression is appropriate? And first, a lot of you might end up taking stats or some kind of stats in the future. And one thing I don't like about AP stats, or one topic I think they could talk about a lot more, is what we can do with regression and lines of best fit and correlation. And a lot of your more advanced stats classes are going to go into this a lot more in depth. And one thing is that most of the time in nature, you're not going to get a linear model. And by linear, I mean a straight line. And here, this isn't a straight line, okay? It's a curve. It looks like I'm trying to think if you guys will know this, because this is like some algebra 2 stuff, but it looks like a rational function, right, with asymptotes. It's kind of approaching a certain value, but just making a straight line wouldn't represent this perfectly, okay? So what that means, as a kind of example, is that there's correlation here, right? There's definitely a relationship between how much garlic you put in and how much food they eat. But that might not be represented in your correlation coefficient, okay? Because R represents linear regression, or at least that's the R that we use in our class, okay? So this question, isn't appropriate because the line isn't linear. There would be a better model, and I'm trying to think while I write, I'll think about it, a better type of function we could use. But you could think that just like in real life, scatterplots could have any kind of equation, And that's when math gets really fascinating and awesome, when you know all this stuff and you're just kind of seeing what works and what doesn't. So yeah, this is like a rational function. So I said that the data doesn't appear to be linear. A rational or logarithmic model would be more accurate. So yeah, that's this question. And I'm going to cover a few more. With the goal of this one basically being reviewing type 1 and 2 error, and also just how to conduct an experiment. Okay, so I think there's going to be a third one that I'm going to go over in this set, but if I don't, there might be some important notes, just because I'm already at 16 minutes. I've taken some breaks, but that seems like I don't want this to be a 45-minute video. 25 would be my max. Okay, anyway, read the question, and I'm going to do this one on a separate sheet of paper, but we're talking about how to design an experiment. On the AP, if it asks you to design an experiment or to design a survey, that's like so lucky for us, and that's something that we can all get points on. And if we're all just shooting to pass, not necessarily get perfect scores, we just got to take the points where we can. And this might catch some students lacking, especially some like super math technical students who might not focus on kind of the logistics of this. But all A says to do is propose a design for this study. And anytime it asks you to design something, you're just going to write a list of procedures, okay? And that involves some sort of random number generator usually, and explaining the treatments and that kind of thing. So it's trying to figure out if music makes you chiller, basically, having a better blood pressure. So that's really a kind of a nice, soothing topic, honestly, to talk about. Just reading this question kind of makes me feel more calm. Like, you could do an experiment of whether or not reading this question lowers your blood pressure. That'd be pretty cool. Anyway, if we're going to design this, we have 100 patients. So the first thing we should do is assign each patient a number. So the way I'm going to try to format this is start with stuff that you always do for a study, whether it's an experiment or a survey, and then we'll go from there. And one note for this is there's a lot of words that mean the same thing in stats, and that can be difficult. So I try to do multiple things, but the treatment group is whatever group is getting the treatment, but you could call that the experimental group. And the control group is the group that's not getting it. And if there was a placebo, then we could also call it the placebo group. But in this case, there's no way to fake listening to music, so there couldn't be a placebo. So a lot of times it's just kind of logistical, logical. So those are the first two things we do, and then let's just kind of define the treatment group and the control group. And then the response variable. And in truth, the first day I taught experiments, like online week 2, day 2, or day 1 or day 3, something like that, has the best design of experiments. But like, I'm just showing you right now how we could do this. But use those notes probably on the test itself. Okay, so that's our design of the study. And now it says the null hypothesis for the study is that there's no difference in mean reduction of blood pressure for the two groups, and the alternative is that the mean is greater if you listen to music. If they reject the null hypothesis, the clinic will offer this music therapy as a free service to their patients with high blood pressure. Describe type 1 and 2 error and the consequences of each in this study, and discuss what you think is more serious. All right, so I love this question. But we're going to talk once more about type 1 and type 2 error. And to do this question, I'm just going to reference my notes from the last question. And if you're doing the test, you can do the exact same thing. Because honestly, and this is pretty funny, like, I have to learn my stuff better than any student knows it. But I still don't remember the difference between type 1 and type 2 error unless I'm actually looking at this graph, okay? Because they both mean that you messed up, right? You made a conclusion that was false. One of them means that you rejected and was actually true, and one of them means that it was true but you rejected. And this question is nice because it's just talking about, in the context of this question, what are the two things that could happen? Like, how could they mess up if they did this survey, right? So the first thing that could happen is a type 1 error, which would be that you reject the null hypothesis. Like, you believe the alternative is true, but actually the null hypothesis is true. Okay? So on the test, just take your time to make sure you understand it. But this is basically saying, if there's no difference is always the null hypothesis. So this is saying that we think there's a difference, but there's actually no difference. The null hypothesis is always no difference, right? We know that this is just like the proportions equal each other. So the proportions are equal to each other, but we reject it. So in this case, we could say, we believe there is an effect. We believe that music has an effect on blood pressure, but it doesn't. And once you identify one of them correctly, the other one is going to just flow as the opposite of that. So we believe music has an effect on blood pressure, but it doesn't. Therefore, the type 2 error is that we believe music has no effect on blood pressure, but it does, okay? And after the first example of this stuff, I feel like it could have been more confusing, but now we've tackled it in two different settings, and I think it hopefully should make more sense. Okay, describe type 1 and 2 errors. We did that, and the consequences of each, and which we think is more serious. And I think that this is kind of opinion, which is fine, as long as you explain your reasoning. Now, both are bad, right? But in type 1 error, it means that they're going to give music therapy to people that doesn't actually work, okay? Now, if you think about that, that's not the worst thing in the world, to make people who like have high blood pressure to listen to music. Even if it doesn't have an effect on their blood pressure, like there's a lot of like kind of like side good things that can come out of it, and not really any harm, okay? So that would be type 1. And if I'm just, now that I said that out loud, that doesn't really seem like it is going to be that serious of an issue. And then for type 2, that would mean that they don't do the therapy, but it would have been effective, because they're saying that music isn't going to have effect on blood pressure, but it actually does. And this is worse, in my opinion, because they actually found evidence that their treatment worked. It's like finding a cure for something, but having it not actually pass your trials. And that's has much worse consequences, because that means that those people who could have been cured or helped are not being helped. Okay, so that would be the consequence of type 2. And then my final thing I'm going to write before I let you read all of this, because I think this is pretty good. My final thought is that type 2 is worse than type 1 error, because they're missing out, basically. And like, this is not the question, but just think that they're missing out, where these errors happen based on luck of the draw, based on your sample. Okay, so if those patients went a different way, or something went different during that day, then they wouldn't have had these errors, and they would have found the correct method. So that's what's really interesting about statistics, right? Like, there's no facts here. There's no way for us to always know, but we kind of just take surveys that are going to usually work, right? These errors don't happen most of the time. They happen less than 10% of the time total. But they happen because, like, that's just the luck of the draw. Okay. So that's that. And that's the last lesson. That's crazy. I was going to do a third example, but I'm at 31 minutes of my recording. And that went really quick. So what that means is there's one topic I didn't teach you that relates to all of this, and that topic is power. And my thinking right now is that if you actually made it all the way to this part of the review, that you're pretty dedicated. and they're already using the answer keys. So when you go through this 6th review set, and when you see the word power, go to the answer key, and I'm going to explain it much more thoroughly there. Okay? So other than that, other than the word power, I think I covered everything. And I'm really, really happy about that. I'm really happy that I made it and you made it, and you're going to crush it on the AP in life, or life and life. If you're watching this, I really think you are. And I'm proud of you. So I will, I think, make like 5 or 6 more review videos that are like extra credit videos or a goodie bag, because there's some things like simulation, a few other topics I might just add. But this is the base of the review, and I'm going to post this video. And the last video of the review set is going to be just me explaining all this stuff. And I'm hoping to post that around Sunday or Monday. Like today's Monday, it's 6 a.m. on Monday. And my upload speeds didn't improve that much, so I think it's going to take like 10 hours to upload these next 2 videos. So 4 p.m. or so on Monday. But anyway, that doesn't matter. What matters is we made it through review. And there's a lot of questions in each one. Just do whatever you can. And remember, the more notes you take, the better. Because 25 minutes for one AP question is actually a lot of time, in my opinion. It doesn't seem like that much, but I think you can crush it. So it was a pleasure. Woo!